I'd now like to introduce our speaker. Named the first William A. Jeffers Director of the Engineering Division in 2014, Scott Hummel has been a member of the Lafayette faculty since 1998. Hummel holds a PhD from Lehigh University, an MS from Stevens Institute of Technology, and a BS from the University of Hartford. He chaired the faculty's Curriculum and Educational Policy Committee for 2 years during the development of Lafayette's new Common Course of Study. He served as head of the Department of Mechanical Engineering from 2006 until his appointment as interim director of the Engineering Division. Scott's research is in the wear of materials. He has published extensively in this area and is recognized as a worldwide leader in adhesive wear testing. Scott, take it away.
All right, thanks. Thank you very much, Chad. And I just want to welcome everyone. Again, sorry we couldn't do this in person, but I think this is the next best thing. My goal today is really to talk about engineering and in the fact of the big changes we see in engineering kind of internationally and nationally, both in industry, but also in higher ed. So those are kind of the key points that I'm going to touch on as we go through today, and really how these changes have impacted Lafayette engineering. So the areas that I really want to talk about are technology. We're going to talk about interdisciplinary, diversity, and of course, affordability. And so we'll touch on each one of these as we go along. So the first one to think about is affordability. And you've heard a lot about this from our president, Allison Byerly. And one of the ways we've done this at Lafayette is affordability through growth. And I like to add in, it's affordability through incremental growth. When we first talked about Lafayette growing, I think there was a lot of angst, both among the students, the faculty, and certainly the alumni about becoming kind of losing that feel of Lafayette as a small college. And that's why I like to call it incremental growth. And when we think about it in terms of engineering, we're talking about 100 students across all 4 years. So 25 students per graduating class of engineering students across engineering. And what I want you to kind of bookmark that 25 students for a second, because 25 students is an interesting number in that we could have taken those students and sort of peppered them across our existing programs. But with 25 students, you could also start a new engineering program. So we had a lot of different options when thinking about what to do with these 100 students across engineering. And of course, when you have affordability, when you think about affordability, one thing that certainly goes along with that is student financial aid. So the college raised about $85 million for need-based financial aid, and that's for the entire college. For engineering, there's certainly a large portion of that goes towards engineering students, and that's made a big difference in making the college more affordable for students that have financial need. So let's talk about interdisciplinary for a second. So for years, engineering, and I think in all fields, things were not nearly as connected as they are today. Today in industry, you have cross-functional teams where you have teams of people coming together, and not even just engineering, but you might have people from marketing, from finance, engineering members, and not just say mechanical engineers, but you can have electrical engineers. So people from all different disciplines coming together in an interdisciplinary team. And at Lafayette, I have to say, we are not built for this. So there's a lot of tradition in higher education, and we are definitely not built for interdisciplinary programs. So we really needed to change how we do business at Lafayette. So on the screen, I've got sort of the abbreviations for the degree programs that we've had, the Bachelor of Science degree programs that we've had for a long time. I call these the big four, right? So you have mechanical engineering, which I'm a mechanical engineer. You have civil engineering, electrical and computer engineering, and chemical engineering. These are the 4 degree programs that we've offered for a long time, the ABET accredited degree programs. And the reason I've got them sort of set up this way on the screen with the lines between them is to really emphasize that they are separate units. I think since about 1985, when metallurgy was was wound down, you really saw where the programs became more and more independent. So when I was department head in mechanical engineering, there was very little shared courses and really very few shared spaces across the engineering division, because each one of these really became independent, which when you think about what that is like in terms of preparing students for industry, this was not really the model that we wanted to go down. Because students and faculty, and to be fair, it's really the structure of the institution, and these things move at a glacial pace. And so you had students and faculty, prospective students that want to work in areas like bioengineering, robotics, environmental engineering, energy. These are interdisciplinary areas. So again, I'm a mechanical engineer. When I see a robot, of course, I view it through my mechanical engineering lens and really see this mechanical device. But of course, an electrical engineer sees a robot quite differently. And the same thing for bioengineering. Bioengineering is really a combination of chemical engineering, mechanical engineering, electrical and computer engineering, these things really coming together. So how do we do something in these areas? How do we offer degree programs in these areas when the college really wasn't set up for this? And so this has really been a focus of ours for the last 10 years. So what we did is we began offering, 2 years ago, we began offering the Integrative Engineering program, or the Bachelor of Science of Engineering. This is a full-on ABET accredited engineering degree. When students graduate in this program, they are bioengineers, or if they're in the robotics track, they're robotics engineers or environmental engineers. They can go to grad school, they can go to industry with these degree programs. But what we didn't do was we didn't say build a new department of bioengineering, because that would just create more silos. So what we did is we created an interdisciplinary degree program. And that really required culture change. And this was, as you know, the culture change is one of the most difficult things to do. And we really built a collaborative climate and a collaborative culture in engineering to pull this degree program off. And I had many people saying, are you sure the students are going to be interested in it? Are you sure we can pull this off? Well, I've got to say, as the expression goes, if you build it, they will come. Our integrative engineering program, in just its second year, has already surpassed the electrical and computer engineering in terms of students, and is equal in size to civil engineering and chemical engineering. And we rapidly see this program growing. And so when we talk about those 25 students that we brought in as we expanded, we absolutely are bringing those 25 students into the integrative engineering program. And in fact, we're pulling some students out of some of the other degree programs as well, which was good because they were really sort of at a tipping point where they were getting a little too large. So this has really helped us to build that interdisciplinary culture. And when you're teaching something like robotics, now our robotics courses have electrical and computer engineers, they'll have mechanical engineers, and they have the students in the interdisciplinary program, in the integrative engineering program, specializing in robotics. So we have all three different types of students, different degree program students in those courses. So the courses themselves have become more robust in that the students have arrived into those courses with different prerequisites, which has really created sort of an interesting environment within the classroom. In order to pull this off, we've expanded the faculty by 2 faculty positions specifically for interdisciplinary learning. One is the Walter Scott Chair of Integrative Engineering. So that person will be the program chair of the Integrative Engineering program. And another is the Air Products Seifi Ghasemi Chair in interdisciplinary education. So the next thing I want to talk about is diversity. As we all know, when you have diverse teams, it not only is it the right thing to do to have diversity, but also the results are better. When you bring in different perspectives, it's no different than cross-functional teams. You bring in different perspectives and you end up with better results. And Lafayette has been a leader in diversity for many years. So when the college went co-ed back in the early 70s, engineering quickly became about 20 to 25% women, which was really a nation. We were sort of on the cusp of being national leaders in diversity, but it's pretty good. I mean, you think about it, the national average for percentage of women in engineering had hovered around 15% for a long time, and then hovered around 18% for a long time. At Lafayette, we were at 25% women for the last 25 years in our engineering division, which is certainly, it's good. It's good, but it's not great. We should be a national leader in diversity, in particular for gender diversity. So when we think about the integrative engineering program with emphasis in bioengineering and environmental engineering, those two fields are #1 nationally in diversity, both in terms of gender diversity and in terms of underrepresented groups, traditionally underrepresented groups in engineering. So this will give us sort of a way to attract more diverse students into our programs. We also added a faculty member called the Kate and Walter Scott Chair, whose role is to mentor and support diverse students and groups in engineering. So with all this emphasis, kind of what are the results? How has this gone over the last 10 years? Well, I can tell you that our most recent graduating class, who just graduated, 2 weeks ago, had 40% women in the graduating class. This is among the highest in the country, and it's certainly the highest at Lafayette that we've ever seen. We are now a national leader in gender diversity. We also have gender parity in civil engineering. So in other words, 50-50 men and women in civil engineering. We're one of only a handful of programs in the country that can claim this. So we're really quite proud of this. We have 1/3 of our faculty in the engineering division are women, and this number is going up. We are among the top 10 in the nation for gender diversity on our faculty. We also have 25% of our students are from traditionally underrepresented groups in STEM fields. This exceeds the national averages as well, with very active SHIP and NSBE chapters. SHIP is the Society for Hispanic Professional Engineers, and NSBE is the National Society for Black Engineering chapters. So we have really robust membership and activity in these areas, which is really terrific and is improving the educational experience for everybody. So let's talk about technology for a second. As we all know, engineering technology is a moving target, right? So you never really get to the point where you say, okay, we're done. We've got everything we need. Engineering is finished. We're satisfied. I had one person say, when are you going to be done improving all the equipment in engineering? And the answer to that is never. There's always changes that are coming along, great things. So I want to talk a little bit about those. And for us, technology really comes down to facilities and equipment. So I want to show you some of the interesting things that we've got happening and the changes that we've been making in the engineering facilities and equipment area. So of course, all of this is grounded in the Acopian Engineering Center. About 20 years ago, the Acopian family made a major gift to the engineering division at Lafayette, and we've renovated the entire engineering building. It's hard to imagine, quite honestly. I've been at Lafayette 23 years now, and it's hard to even think about that the Acopian renovation was 20 years ago. But it was, and so it's now honestly time to renovate again, and we've been in the process of doing that over the last couple of years. But really, this is all predicated on the major gift that the Acopian family gave us. So one of the areas that the expansion has really helped us is, so with the expansion of the student body from about 2,400 students to about 2,900 students across the entire college, what has happened is we've taken sort of non-core activities and moved them off campus. So when most of you were here at Lafayette, facilities was on campus. In particular, the facilities where they did the groundskeeping was actually in the Acopian Engineering Center. In the sub-basement of Acopian was the area where the lawnmowers and whatnot were repaired and stored. Well, as we're expanding, we've taken all of those operations and moved them off campus, which meant that the academic division took over those spaces. So we renovated the sub-basement of Acopian. If you were here, if you're from the class, I see a couple people from the 50s and 60s. Now, if you were here in the 50s and 60s in the sub-basement of Acopian, that's where the foundry was. And the foundry somehow ended up in the hands of facilities. I don't know how that happened, but we have wrangled that space back. And that is where Leopard Works is kept. So Leopard Works is this hands-on space. As you can see on the photo on the left, that's a classroom. And that is a kind of a hands-on classroom. You can see it's very, it's not a traditional classroom, right? It definitely has this sense of building and making. On the right-hand side is our maker space. And there's a student in there who's putting a part into one of the 3D printers. So we've got a 3D printer farm down there, we call it. We've got over a dozen 3D printers that are down there with full open access. Students can go down there and use them kind of at will. We've got 3D printers. We've got a circuit board printer, vinyl cutter, things like that, laser cutters, and those are for use by the students. So this has been really terrific for building sort of that maker culture down there. One of the things that we've definitely seen is this, by having this collaborative environment, and honestly, to be completely blunt with you all, I didn't see this one coming. When we built this interdisciplinary culture and this climate of collaboration, you know, you always know that in engineering, you're going to need to upgrade equipment and you're going to need to upgrade spaces in order to house that equipment. What I really wasn't thinking about 5 or 6 years ago when we were thinking about the renovations in Acopian were that the spaces were going to need to change to support the collaborative climate. And we've certainly seen that more recently. This is a space that we are renovating like literally as we speak. This is a space that the renovation started just this past Monday. It will be done by August when the semester starts. This is on the 4th floor. This is part of electrical and computer engineering. And this was the old circuits lab, and this is being converted into a much more collaborative space. You can see these lounge spaces on the front, and these lounge spaces are, when you have this collaborative environment, you need spaces where students can casually have conversations. You know, this is sort of the water cooler conversations when you're in the office, and these casual conversations, and when students are hanging around and they're at these chairs doing homework. These are really important to have these spaces for people to be able to work together. And to the left of that screen, kind of in the back, you can see with the red chairs, that is it's a glass-walled collaboration space where the students are these are very flexible spaces. The tables that are used have computers that are completely hidden, and then they're in the stored stage right there. And the computers literally slide out from underneath. There's a widescreen monitor for the students to sit around a table and collaborate. There's projection systems. You can see all the writing on the back and the wall. That's a whiteboard wall. The students can literally write on the walls of these spaces. They're very dynamic, very collaborative. And one of the things that we've seen in these spaces is the diversity of the students that are using these spaces. They feel comfortable, they feel inviting, and more students are using these spaces. Particularly now that we have a lot more women in the engineering spaces, these spaces are so much more inviting than sort of the old, you know, block walls with very little natural light. So you can see the natural light pouring into this entire area, and it's very, very nice and comfortable space to work in. Another space that we're renovating again as we speak is down in mechanical engineering. This is a space that had no natural light in it whatsoever. We're taking a faculty office, which is the one on the right. There's a faculty office or two that's got those windows in it, and we're opening those windows into a glass walled space. You can see the collaboration zone there where the student's backpack is resting on the chair. And so this is a really nice, again, it's similar to the one that you saw up on the 4th floor. This is in the back of the 2nd floor, what used to be called Dana Lab. So this is back there. If you were here in the 50s and 60s, Dana Lab certainly did not look like that. And the room on the left is also there in Dana Lab. Just across the hall from the one on the right. So you can see these spaces are very flexible, collaborative. We can use these spaces, believe it or not, that lab on the left is used for instrumentation, controls. There's lockers there. You can see up against the wall in the picture on the left. And those lockers store the equipment, things like oscilloscopes, voltmeters, data acquisition systems. They've shrunk in size to the point where they're literally not much bigger than an iPad. And so a lot of these systems and a lot of this equipment that used to be very large and make a lab sole purpose can now be stored in these lockers. Students and the rooms can be used for multiple purposes. One of the things about the engineering facility is some of the spaces had very low utilization rates because they were dedicated labs for, say, controls or data acquisition. When you have a room like that, you can only use it when those labs are running. And so these new flexible spaces give us much more ability to use those rooms. So one of the things that I'm most excited about is the expansion to the Acopian Engineering Center. So in this view here, you can see in the late 60s, the addition on the on the right-hand side of Acopian was added. And that addition, I'm not sure why, but it was only made 4 floors tall. You can see there's 2 floors above grade. Keep in mind, Acopian is built into the hill. So you can see 2 floors there. And so what we're doing is we're adding a 5th floor to the Acopian Engineering Center on the Markle side of the building. And it's really going to be a terrific space. It's mainly classroom space. And the reason we did that is the larger classrooms in the Acopian Engineering Center only have 8-foot ceilings. And when you're in a large room with an 8-foot ceiling, it feels almost like you have to duck when you're in there, just because a large room needs a higher ceiling. Just the aspect ratio wasn't really right. And so what we're doing in the new addition is we can build it as high as we want. So we're putting 11-foot ceilings throughout the space. And so it'll have really nice classrooms up in there. And then the classrooms that are in the rest of the building, I think we're taking 4 classrooms and converting them into different laboratories. So that's really terrific. And this is going to be called the Walter Scott Pavilion. We're doing some preliminary work in this on the rooftop this summer, but construction will begin in earnest in December. And the Walter Scott Pavilion will be completed by a year from this coming August. So August 22, this space will be opening up. So some additional things on the horizon. So as we've gone and opened the integrative engineering program, and as we've become more collaborative, we need to add a bioengineering lab, a robotics lab, a materials lab. So for those that were in the metallurgy program at Lafayette, we are essentially going to be bringing that back in a sense, in that it will be part. I think in the next couple of years, we'll be adding a materials focus area to the integrative engineering program. So essentially, a student who graduates from the integrative engineering program with a materials focus can go on to graduate school in materials, whether that's composites, polymers, or in metals. We're going to add a dirty lab, and what I mean by that, especially in the civil engineering program, there tends to be large dirty projects, things like concrete, and also the environmental projects. So we're really talking about kind of big, messy projects. They're going to be down along in what's called the Reineck building. So the Reineck Rope Works was down in what we call Lower Campus now. It's backed by the Hummel Lumber building, no relation on that. But on the back side of campus, where the campus has expanded, the college has acquired the Rheineck Rope Works, and we'll be putting a dirty lab in there. And also classroom updates. So these are some of the things that we'll be doing in the future. And I also want to add here that all of these spaces, all of the equipment within these spaces are funded through our annual fund program. And I often have alumni say, well, you know, I'm not a very big donor. I just give a small amount to the annual fund. And they'll say, but, you know, your endowment is much more, you know, impactful. And I always push back on that, because from the endowment, and this is true really of any college and university, we can pull about 5% out of the endowment per year. And that can go towards things like building projects and whatnot. But the annual fund, we spend that money, just like it says, each year on equipment. So a $100 gift to the annual fund is worth $2,000 it's worth 20 times that in endowment, because you can only pull 5% out. So something like $1,000 gift to the annual fund is equivalent to a $20,000 endowment. So it really makes a huge difference. I tell our students all the time, every piece of equipment that they touch is given to us through the generosity of the alumni and friends of Lafayette. So it really is hugely impactful, and the equipment in these new labs will be funded through that. So that's really the end of the remarks that I wanted to give, and I want to turn to the chat now and see the kinds of questions that people had, and we'll go from there and kind of have a free-flowing conversation from here. So Chad, what do you have there in the chat?
Well, Scott, we had some very initial early comments talking about just the applauding the growth of what the program has gone, especially from those who you know, have heard from you over the last 5 or 6 years. So it's great to see. I think
great.
What you're doing there. Question just came in here. Do you see any fundamental changes to engineering program with the announcement of President Hurd? I'm not sure if you've had any conversations with her initially yet about the program or how that might be moving forward.
I haven't had any conversation with the new president, and I'm looking forward to that. I think the direction that we've been going with the interdisciplinarity and the diversity are probably the two big pushes that will continue for the next few years at Lafayette and you know, at schools across the country. We've been incredibly successful in doing that, largely with the support of the alumni. I think one of the worries that we heard years ago when we started these changes where people were concerned, I can remember the exact phrase was that they were concerned that we were watering down engineering. And I assured people that that was not the case. And really what we're doing is giving students that, I think, preparing them better for either graduate school or for industry in thinking about, you know, in working on these interdisciplinary projects. I think, to answer your question a little bit more, Chad, when I think about capstone projects are going to be, so this is an area where, keep in mind, our integrative engineering students just finished their sophomore year, right? The first cohort of integrative engineering students are just finished sophomore. So next year they'll be junior year, the year after that they'll be seniors. And I think the biggest push that we're going to see in engineering in the next couple of years is collaborative capstone projects. So right now, if you're a mechanical engineer, I'm a mechanical engineer, like I said, mechanical engineers basically do capstone projects with mechanical engineers. We've had some integration with electrical and computer engineers and the mechanical engineers with the formula car project, the electric formula car. But I think you're going to see this more, and where I think the new president can really help out is doing capstone projects across the institution. That's really, to me, the gold standard. If we can get to that point where we've got economics students, art students, you know, I don't know what all students on these projects, I think that would be really fantastic.
Thanks, Scott. Another question that came in, you talked about the annual fund. Can you talk maybe a little bit about how much funding do you also receive from other external sources, whether that's federal grants, commercial grants, or how those come into play?
So NSF we've been very successful with the National Science Foundation with getting grant money in. And let me explain a little bit more on that. So NSF has a program called a Major Research Initiative, MRI grants. And what these grants are for primarily undergraduate institutions for equipment. And they tend to be large. They don't want a $50,000 grant proposal. They want, $200,000 grant proposals and upwards of that. And we are very successful with those. In general, NSF grants have a success rate of something like 5% or less for a faculty member at any school applying for an NSF grant. At Lafayette, our hit rate on these MRI grants is at least 25%. I think it's about a third, quite honestly. And that's much, much higher than the national average. And the reason is because Lafayette is engaged, all of our faculty are engaged in research. There aren't many schools that are undergraduate only that are engaged in high-level research. So there's only a few schools that we compete with for these grants. And so we've been incredibly successful with getting things like scanning electron microscopes and some other very high-end in electrical and computer engineering. They bought a multi-channel network analyzer, I think it was 2 years ago, that was, I think it was $300,000. And those kinds of things, we've been very successful with buying large pieces of equipment through NSF.
Thanks, Scott. Another question that we had, is there an intro engineering course for all students to help decide their major?
Yes, there is. In fact, we've changed our intro to engineering course a couple of years back. Now, we've had intro to engineering for, it's got to be 25 years or so. We've had a division-wide intro to engineering course. And we've gone through different versions of it. The one we're doing right now, I think, works quite well. And let me give you a quick history of how our course has gone. So at Lafayette, sort of in the spirit of the liberal arts and a liberal arts with engineering school, we want to give students flexibility to change their major and not be admitted into an engineering major that then you can't switch out of. So one of the things that we find is students don't have a great sense of what type of engineer they want to be when they arrive at Lafayette. So our intro to engineering course is set up like this. It used to be where students would be exposed to all of the different varieties of engineering. So all of the different Bachelor of Science degrees in particular. Well, in a 14-week semester, when you've got 4 different engineering programs, you were really kind of in and out of each program so fast that you really didn't get a good sense of what they were anyway. Then we went to the model of having one engineering. So we went kind of the other end of the spectrum. So we dropped the 4 and went to 1, where students would be in one program. That didn't work well either. So now we've sort of gone halfway in between, where we teach it on a modular format. There's 2 modules. Students get a list of the modules that we'll be offering during the summer. So in about 2 weeks, we'll be sending it out to the incoming students, and they rank which modules they would like to take. And then we place the students based on their preference into those modules. So this way a student can be exposed to, say, robotics, or they can be exposed to energy. And we try to keep the areas at a pretty high level and not have it be sort of a micro look at electrical and computer engineering, but more of a holistic view. And so that works really well. It is required all of our students take the course. We don't give AP credit for any student for intro to engineering, because even if they've had intro to engineering in their high school, we want them oftentimes is not taught by an engineer, and we want students to take our intro to engineering, and really what it does is sets the students out on that path. But so the long answer to your question, Chad, is yes, we offer intro to engineering.
Thank you. Another one here, Scott. The 2016 bridge build project was very impressive. Any plans for something else along those lines? Across the globe, the annual Construction event occurs, charity event aligned to food insecurity, in which engineers, architects, students, construction, etc. industries can use canned goods to build sculptures. It is a judged event, and the creativity is amazing. This would be a cool collegiate initiative. So combination question and comment in there, Scott.
Yeah, so we love doing those kinds of events. In 2016, we did the bridge, and I think it was 2017 or 2018, was it, that we built the geodesic dome on the quad for a reunion. That was great fun. And that was coupled with, it was a Buckmeister Fuller. He was the developer of the geodesic dome. If you're familiar with the Epcot Center, right, the big sphere at Epcot is a geodesic shape to it. And so we built one of those on the quad. And what we try to do is couple with partners on these projects. That CAN project sounds really interesting, and we could do that and possibly connect to art, the art department. But we love these kinds of projects. There's nothing right now on the horizon for doing those. We generally come up with these ideas in the fall, but I'd love to get more information on this CAN project and maybe connect with some of my colleagues in art. What tends to happen on these is we connect with another department, we get some energy around it, and it just really flows from there. The project on the bridge with the 150th of the bridge was really terrific. That was just an amazing project. For anybody who was here at Reunion for that one, we built a 150-foot long replica of the Free Bridge of Easton on the quad on Reunion weekend. And we built that thing in 4 hours. It was amazing. In fact, a picture of that is now in our lobby, a great big picture. It's wall-sized picture of this is in our lobby. So that was a lot of fun. And we'd love to, if you have ideas for projects, whether it's the CAN project or other ones, send them along, because we'd love to connect on some of those.
Thanks, Scott. Question here of what did the lack of hands-on labs this year do to any of the programs? And are there contingencies in the future kind of along those lines?
Yeah, this was the most challenging year. I mean, I'm sure all of you, everybody has their COVID story and stories, and it was challenging and I'd even say traumatic to everybody across the globe. And it certainly was impactful to what we could do in our engineering programs as well. Let me just take a second to brag about a couple of our faculty and what they did. And one goes to the mechanical engineering faculty that were teaching controls. So the way we typically do control systems, and this goes for instrumentation, is, I mean, you're alumni, you remember what it was like. It's a hands-on experience. And this past semester was actually not bad, because we had most of the students were on campus for this past semester. But for the fall, and for the fall was the one that was really tough, because last spring, a year ago, we just sort of slammed like the rest of the world, you just sort of slammed everything shut and dealt with it as best you could. But for the fall, we needed to up our game. So what we did is the instrumentation or the control systems that we work on are these large, in mechanical engineering, are these large benchtop units. They require fairly large data acquisition systems to use. There were pretty large motors and all the other pieces. And we had 6 lab stations, back at Lafayette, and the students would come in and use that equipment. And what our faculty did is they built these miniaturized versions of this lab setup. And our technical staff produced 60 of these, because we have about 60 mechanical engineering majors now. So they produced 60 of these last summer, and we shipped them all over the globe. And literally the students had a hands-on experience in their home. And we had students all over the globe. I mean, across the US, Canada, into South America, Asia, Europe, all students working on these things. And it was really incredible in how well it worked. How that will impact us moving forward is really quite amazing, because some of these pictures that I showed you, especially of the mechanical engineering lab, which has no equipment that are sort of dedicated equipment, some of that was inspired by the things that we did during COVID, where now we've taken these benchtop units. We've said, look, these things worked really well. I mean, the units probably is only about this big. You could hold it in your hand. And so what we're doing now is we're literally sticking with that design for the data acquisition and controls lab. And students are going to be able to have these things, in the classroom, in their dorm rooms. We're still going to have labs where the students bring these in, they'll be modifying them, but it's really helping us be better. And I said this when COVID hit, that we're never going back, so to speak. We're never going back to the way it was. This will change what we do forever, and we will be better for it. There were times where I needed to really convince myself of that, but it is turning out to be true. We are going to be better for it. I think we're better educators for it. I taught a strength and materials class. I can say that I've never worked so hard for a lecture class as I did during that strength and materials class that I taught last fall. Because to really engage students in a Lafayette-worthy education, it just took an incredible amount of effort, and our faculty did it. I mean, you all know our faculty, that they are here for the students, and that has never changed and never will. And so the effort that went in, the Herculean effort that went in to make it Lafayette worthy, that's the way we would describe it. I would say these courses need to be Lafayette worthy. They can't be an edX or Coursera. You can find online courses all over the place. They need to be Lafayette worthy courses. And that's the metric that we use when we're on campus. And that's the metric we use during remote.
That's awesome, Scott. I remember some of the conversations I had with you early on, and just to hear some of the thinking and to actually have it all come to fruition is terrific.
Yep.
Another question in here. What is the proportion of engineering graduates going on to employment, graduate school, or doing something else?
Yep. So about 20 to 25% of our students go on to graduate school directly in engineering, directly from Lafayette, which means 75%-ish are going into industry. And in general, well, first of all, the 20 to 25% that are going on to graduate school are doing that with full funding. So they're going to the best graduate schools in the country. The #1 recruiter of Lafayette alumni in engineering for engineering graduate school is Cornell. And then next is places like Virginia Tech, Georgia Tech, University of Virginia, University of Illinois, in particular for civil engineering. They love our students, and they're #1 in civil engineering in the country. So best schools. Purdue is another one that we send students to regularly, even MIT, the Ivies as well. So we are definitely putting students into those programs, and they're doing so with full funding. So what I mean by that is the graduate schools are paying our students to attend. The students aren't paying out of pocket. The students get a stipend and tuition remission to attend those schools. 75% of the students are going into industry. In general, those students are going into entry-level engineering positions. The job market is fantastic. We were quite worried, as everyone was, of course, with COVID, that the job market was going to take a downturn. That really hasn't happened in engineering. Internships were definitely slammed shut last summer, and we were worried how that was going to impact employment. It really hasn't at all. So our engineers are absolutely getting jobs, and great jobs. When we talk about it, I say, our students aren't going to work at Denny's. they're getting good, they're getting good permanent jobs at really great employers. And we appreciate all the work many of you do in that area too. You're the ones that are connecting our students. I always say to prospective students, the placement of alumni is directly connected to your relationship with your alumni, because those are the connections that are formed that are placing students into positions. And if you look closely at my name on my picture there, you'll see it says P21. So I'm a proud parent of a recent Lafayette alum in geology with a minor in economics, who was connected through career services to the parent of a current student. And he's going to Denver. We're bringing him out to Denver next Thursday, where he's got a job as an analyst for a mining company, a private equity company that invests in mining. They hire geologists with a finance background. Sounds like a Lafayette thing, right? So it's really perfect.
That's great, Scott, and congratulations on great achievement as well.
Thanks so much.
Two comments here, and then another question. One is a comment that really just wanted to specifically applaud the diversity and increase in gender balance that's been taking place when you highlighted those statistics earlier on in your presentation. And then also another comment, just acknowledging what you spoke about a few minutes ago about that Herculean effort that went into redesigning a lab-based course during COVID. And just so kudos to the engineering, bio, chem, physics, neuro, psych departments for all that work that went into that.
Yeah.
Question here that of course starts off with a joke, and any shot we can take at one of your other alma maters over there though. There also used to be a joke that Lafayette can build, Lafayette and MIT can both build a car, but you are from Lafayette if you can also drive it. Any homes or car prototypes on the horizon?
I missed the second part. What was that? Any what?
Any home or car prototypes on the horizon?
Home, like a house?
Yes, I'm seeing a nod of yes.
Yeah. Okay, so we do have the Formula Car project that is ongoing between electrical engineering, electrical and computer engineering, and mechanical engineering, our general. And now we're getting, I think we're going to see some integrative engineering students hopping on that project too. So that's an ongoing project, really a terrific project, and they're building an electric formula race car on that. So that is definitely ongoing. As a mechanical engineer, we always have students that are interested in cars and planes. Those are sort of, certainly some bread and butter there for mechanical engineering. So we always have projects in those two areas. Sometimes the plane projects is more like aerospace type projects. So it might be a plane. We often do this project connected to NASA where they build a rocket. And these are pretty serious rockets. We're not talking about like a backyard kind of hobbyist rocket. We're talking about, a 10 foot tall, rocket that might be this big in diameter to go to altitudes of a couple miles. So it's really pretty amazing what they're doing there. As far as home projects, they're more related to solar energy. And I think that's where students have a really strong interest there is projects related to energy, and solar is certainly one, and wind as well, but really it's mainly solar at Lafayette, where we have students that are interested in these projects and building some really cool hands-on projects. I'm not really sure where they're, kind of where they're going with that and where that will land. That's not like the Formula Car where it's an annual project, or a perennial project, I should say, but these projects are definitely gaining steam, and especially with the integrative engineering with a focus in energy, I think that will grow more as we move forward.
Thanks, Scott. Do you have a few more minutes if there are any other questions that anyone would like to pose into the chat? Or if you'd also like to raise your hand, I can also acknowledge you that way if you want to ask a question that way as well.
Chad, I would add, if anybody's putting in that, that's great. That I give a lot of talks to prospective students And one of the things that I emphasize to them is that the alumni network is so important to the success of a college like Lafayette. And that occurs in a variety of different ways. It could be guest speakers, it can be employment opportunities and internships and externships, job shadowing type experiences. It could be financial, where alumni are making gifts to a place like Lafayette. But all of that enriches the undergraduate experience. And as I look at the success that we've had in engineering while I've been director, I can absolutely say that I and we, the engineering division, would not be where we are today if it were not for the alumni that we have. When you get a chance to come back to Lafayette and see the engineering facility, it's absolutely fantastic. The changes that we've made to make the place more inviting, to enhance the education of the students, to make it more collaborative, prepare students for industry. And as I tell prospective students at Lafayette, and this is true when all of you were here, and it's certainly true now, we're not just educating engineers. What we're doing is preparing the next generation of leaders. And we continue to do that. That's a long-held tradition at Lafayette. It's not just not that there's anything wrong with sort of a pure technical education, but that is certainly not what we do at Lafayette. We are preparing the next generation of leaders in the country and in the world, and we are doing a great job at that. And a huge cause of that and enabling force of that is the alumni network in all of its forms. So I want to really thank all of you for your support of the engineering division, of me and my efforts, and of the college in general. And I look forward to the new president, to see where she's going to take us. And also, we've got the 200th anniversary of Lafayette is right around the corner. So we started, of course, as you know, in 1826, and 2026 is right around the corner. So we're kind of ramping up to that, and that's going to be just a great run from now till then. So I'm really looking forward to that, and to see the things that we can do between now and 2026.
Beautifully said, Scott. Beautifully said.
Yeah.
Any other questions from folks here before we end our session? Again, you can either raise your hand if you want to put anything in the chat. I do want to also remind everybody that we do still have a few more sessions yet this afternoon as a part of virtual reunion weekend. We do have a series of class happy hours scheduled at 5 o'clock, which you can find as well. And for those of you who have been playing along with the week-long codes and competitions, I did put in the chat the code for attending this session here with Scott today. That code is AEC21. Don't think I'm seeing anything else, except for a lot of thanks and congratulations to everything. Scott, I think everyone had a just enjoyable time hearing your updates and direction of where the program is going. So thank you so much for that.
Thanks so much for coming, everybody, and enjoy the rest of the reunion, and we look forward to seeing you in person soon on campus.
Thank you, everybody. Enjoy your rest of your day.